These books be passed out and make them leaders. Send your follow-up messages to contact or your donation item. All students are welcome today to Forum Friday if you'd like to go through. Talk about cryptocurrency today at lunch. Another reminder, next Thursday, February 17th,
Maria's
the third
still
quarter.
Mariah.
Teachers always great doing that. Visit with the teachers. Utilize your part-time until next Thursday. All please remain to the flag.
Eli.
Great day and great.
Finn Kai. All right, do the thing. Remember, this is your gut check. This is, do you know it? Not your buddy knows it. Do you know it? We good? Should be. I pulled this problem from the problem set in section 2.6 of the Algebra 2 book. You done this plenty of times. Do we remember how? First, who's your daddy?
Absolute value of x.
Plain old absolute value. Okay? The parent function is just absolute value of x with nothing else near it. After that, we did 4 things. Someone right now is already going, wait a second, I only got 3. Did we remember to separate the vertical reflection from the dilation? A does 2 different things. It has my reflection in the x-axis, or a reflection in the x-axis or vertical reflection. And it has a vertical stretch, or you could just say dilation, by 3. Then, plus 4 is in bass-ackwards land, so I'm going to go horizontal translation, left 4, positive 6 in the K spot, so that's a vertical translation, up 6. No, we'll just keep this. So I'm going to take my vertex, I'm going to move it, left 4, up 6, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. And then, normally, it's a V headed up with a slope of 1 on the right-hand side. I'm going to take that, reflect it, and triple the rate. This is also why we said that my vertex is at HK, and the slope on the right side is A times B. A times B, negative 3 by 1. Slope on the right-hand side is down 3 over 1. And I reflect it across that axis of symmetry. Connect the dots. Okay. So, did we state the parent function? Did we get our reflection and stretch correct and separated? Hi.
In Algebra 2 in Mr. Spears' class, he just taught us to do it at the same time and not separate them. So if we didn't separate them, is that a point off?
But it is 2 different transformations. Like, what do you mean,
So
do
like,
them at the same time?
So like, for negative 3, it'll just be like, okay, stretch at 3, it's pointing down. Instead of its reflection, and then it's a stretch.
I mean, that's what it does, but if you're listing the transformations, there are 4 transformations. Like, they happen in the same spot, you do the same thing with them. In Algebra 2, that's what I told kids. This is just your slope on the right side. But if we're stating all the transformations, especially all the kids we were doing ACT review this week, they love hitting you on little stuff like that, so that's why we're separating them. I'm going to say, did you not just have the horizontal and vertical translations, but you had the direction correct? Because sometimes we'll goof up and we'll say right 4. Sometimes we'll have the right idea, but we swap which one is horizontal and which one's vertical. So I'm going to say 2 for that. There's a little more going on there. And then, does your graph actually match?
Why not that? Why wouldn't we do like the absolute value transformation route with the pins like what we did yesterday? Where it was like, you know, where it was like in the absolute
Because
value.
we're not doing absolute value of just input or the whole function.
Oh,
Absolute value transformation would be if I just did that. Suppose I shouldn't be on highlighter mode, right? If I just absolute valued this, then that would take this stuff and overwrite this stuff. Versus if I absolute value the entire function, all of it, that would take this graph and send these up here instead. But because it's the parent function itself, suppose you could say the parent function itself is a absolute value transformation of a linear function. That works. But the translations themselves were, for absolute value, were either just input or whole thing. This is like part of it. So I go with the parent function instead. Anything else about it? Okay. I did not hear any questions about this other than, is that really our assignment? It was a little bit longer than I would like, but if you notice, it was literally like one of each. It's just, it took us 2 days to do the lesson. So 2 days worth of stuff. I hope it wasn't too terrible because it was mostly just name the transformations. So I hope the timing was still not bad. How are we doing on those so far? Like, are we sitting at that 30 minutes or less Domino's delivery time? Okay. Now, sometimes you get wrecked by a big word problem and just takes you longer to puzzle it out. But a pre-calc assignment of typically about 6 problems should be about that 20-minute range, give or take, depending on processing speed, depending on whether you're distracted or not. Okay. Like, seriously, is anyone running that 30 plus minutes on your assignments distraction free?
I would say yes, but not distraction free.
Yeah, if you're doing your assignment and you're dinking around with your phone, you're texting your friends, you're watching Netflix, you have to watch your younger siblings, like you're staring lovingly into the eyes of someone, whatever it is, I mean, yeah, that's going to increase your time. Nothing? Like, it's going okay? Because if I need to bring it down, I can. I've just got to be very, very choosy about which problems I'm doing. All right, then you go away. 1-6. We added, we subtracted, we did not have the opportunity to do it on our own, right? We got through multiply and divide, example. We just didn't have the chance to try it on our own. So, right, that's right when it went ding. So, there you go. So, 1a, 1b, right where we left off, there's a function rule for f and g for both of them. Add them, subtract them, multiply them, divide them. And more importantly, tell me the domain on each, because we need to practice domain. This you puzzle out with your neighbors.
Just X by the square root and then maybe the by square root. So just get 6 minus 2. Just distribute it.
And keep going on both of them. I'm just making pretty colors. Okay. Round 1, add, subtract, multiply, and divide them. Can't combine any terms, but did anyone catch that the correct way to write this was radical and then minus 4? Now, it's fine if you didn't, but why? Why would that be prim and proper, James Bond in a tux, cufflinks, and everything? Y'all remember standard form being in descending order for polynomials? What's the degree on x? What's the degree on 4? 0. What's the degree on 9 minus x squared? 1/2. 1, 1/2, 0. That's getting real picky. I would not take points off for that anywhere, ever. But someone might get you. I ain't gonna. And then just x minus that. multiplied. It's just ugly. X root of 9 minus x squared minus 4 root of 9 minus x squared.
Is that simplifying?
Okay, I had a couple talk about this the other day. I can't take anything out of that right now because it's a difference and not a product. See, if that was 9x squared, well, it's a product. So square root of 9 is 3, square root of x squared is x. If it was 9 minus x, the quantity squared, well, now that's something times itself. But because there's a difference in between them, I can't actually take anything out because I don't have a repeated pair of factors. Okay, so it just stays like that. This one, did we remember to rationalize? No radicals downstairs. So I have to multiply numerator and denominator by that and say that's x square root of 9 minus x squared minus 4 square root of 9 minus x squared all over 9 minus x squared. Because I have to rationalize. I have to multiply by that radical, top and bottom. No radicals downstairs. Domain. Contestants 1, 2, and 3 all share the same domain if we got to go back to that number line. We know that something's going on at plus or minus 3. Because that's how I would solve my radicand. So, pick numbers. What if I picked 0? 0 is legal. What if I picked 4? It does not work. So that means the domain for all 3 of these is going to be from -3 to 3. What changes for the division problem?
You can't have like 0.
We can't equal 3 and -3 because then we would be dividing by 0. So it's very, very similar, -3 to 3, excluding the boundaries. Okay? You test what is legal and what is not. Your 3 commandments of domain. I can't divide by 0. I can't do even root of a negative. No logs up here. Okay, the first 3, the only thing restricting it is it's got a radical. So I got to make sure I only put in numbers that are going to give me 0 and above. Specifically because it's an even radical. If it was cube root, you'd be fine. And then the last one, I have to exclude the values because either of them makes divide by 0. Should have just made that bigger for one problem. All right. What about that guy? I'm guessing we got the first one done and then, or maybe 3/4 done and then started kind of going cross-eyed on the divide part. Try it again. Same thing. You got a polynomial and a radical. Radical. Words are hard. Okay. Start all of them the same. FG, 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 with different arithmetic operators in there. Well, I suppose we need to stop saying that. That's like algebra 1. Mathematical operators. I want to be careful not to say arithmetic operators because that's arithmetic series where you're adding every time. Geometric is multiplication. Okay, can you properly combine terms? Can you define the domain? Hmm? Is it what? Is it? Okay, this using the black marker as an eraser like that. Yesterday's second hour, Logan Brewer absolutely blew his mind. Kid was freaking out the entire time, like Thunk from the Croods freaking out about the window. He was losing his mind because we could use black to erase things. He's doing it again! It's so cool! Like, Bud, are you really geeking out about coloring? So, yes, it is -8. Then, with each of these...
Hold up. Isn't that a brownie point?
Yeah, I'll get there. I want to finish the problem. X squared minus 6x plus square root of x minus 8 if I'm putting things in order. Domain. Who's not allowed to the party? So, my domain is 0 to infinity. Okay. I'm hearing the word factor. Just because you can factor doesn't mean you actually factor. Okay. If just writing what it is, I want it in simplified form. As soon as I include parentheses, it's not simplified anymore because parentheses imply there's an operation to be performed. Okay. That's like, I don't know, given my sister-in-law our old crib. If I give it to her in a stack and a bag of bolts, say, here's your crib. I didn't really give her the crib. I gave her the crib, some assembly required. Okay? If you factor this part, well, you just got more parentheses. You took it apart, not put it together. Okay? Same thing, except minus square root of x minus 8. Absolutely butt ugly. X squared square root of x minus 6x square root of x minus 8 root of x. Same thing. Curious. Did anyone go... What? I just put x. What do you mean?
X squared. The first one.
Oh, this one?
No.
No, I'm not on this yet. I want to know, did anyone do this? 2.5. 1.5. 1/2. Did anyone go to rational exponents? Can I? Okay. Just want to throw that out there. Times square root of x times square root of x is x squared square root of x minus 6x square root of x minus 8. Square root of x all over x. Do not try to do something like that. That's heresy, yes. I think McCreary has the every time you do this, you kill a puppy poster. Like, don't. Math is communist. What you do for one, you do for all. I cannot take an x out anywhere unless I can take it out of here and here. And since that last term doesn't have another x to get rid of, 'tis impossible. Okay, and then the domain, again, it changes to 0 to infinity, excluding 0, because you can't divide by 0. Huh.
We're trying to keep the domain real at all times, right?
The domain will be all real numbers, yes. Like, you can't have a domain that includes imaginary numbers. Like, oh, I take that back. We can't do that now. All right. Those both involved radicals. I want to see if you can do this when the radical disappears and you just got to work with the polynomials. But, yeah, 4. I'm going to change it. Why would he do such a thing?
I don't really want that. But I think you have time for the brownie point now.
Yeah, I do. Found our class attorney. You know, that's how the list of shames started. Was someone arguing so much about brownie points that they made me screw up. I was like, no, you don't get to call brownie point because you made me mess up about the thing you messed up. Screw it, Morgan, you're going on there.
Oh, that's scary.
All right, you do that. Class mom, you're in charge.
For some reason, I didn't put the problem from yesterday, but I was going to check the swap out numbers.
Are we supposed to then I read that?
No, I don't think we're supposed to. We're supposed to make it as simple as possible.
But can you cross out? Yeah. Like, the domain would just be, you can't have zero and one. Well, no, it'd be positive. No, it would be negative. I do love that. It's okay, I'll just, I still do the same thing. It's fine. Yeah. I just thought it was.
I don't know. We were partying back
The first one would be a positive 20, the second one would be negative, the third one would be minus 32,000. And then last one, yeah. Plus 20.
Oh, yeah, of course.
Or would you need the negative for the? Yeah, no, I don't understand. I understand. Why would you do that? Because.
It's 40x squared. Do. Oh, I forgot to put my squared up there. Damn it. Okay. Yeah. Right, because 2, 4x, 1, 4. Yeah, I forgot my squared. I was trying to make a reducible. Fine. I forgot to put that there. Yep. Yup. What do you mean do anything with the graph? There is no graph. So I forgot to put the squared there. I was going to have them cancel. Oops. So it ends up that's just the answer. For the domain, you just set your denominator equal to 0 and solve. That's the thing that's not allowed.
If there's a hole, do we have to specify?
You don't have to specify that it's a hole, but you do still have to exclude it from the domain. Okay, that was something we learned with rational functions. So say this was, say I actually remembered what I was doing. Not 16. Right? 2, 8, 4, 32. Okay. Say I had that instead. Break it into x squared minus 16, which then is 2x plus 4x minus 4. If I could cancel out those x plus 4s, you have a 2x minus 8 left up top and just a 5 on the denominator when you simplify it, but there's a hole. So you still would have to exclude that from the domain. Even though you don't see it in your end result, the end result is kind of like the after party. Who's not allowed to the after party? Well, no one. But you had to be allowed to the party before you could go to the after party. Okay, think about prom. The after prom thing, you know, you got all the casino games and the inflatable smack each other jousting sticks. They still do that? Okay. You're not allowed into that if you weren't already at prom, right? So if you're not allowed to the original version, then even if it reduces and you don't see it anymore, it's still not allowed at the after party. It's still not allowed at the final result. And I tried to do that on mental math on the fly and it didn't work.
So why is the domain still, you have to,
Well, I have if I have this on my denominator, I'm still not allowed to have an x minus, or a negative 4 for an x.
the rule is just if it's on the
Your 3 commandments of domain. Thou shalt not divide by 0. If I've got any variables on denominator, set my denominator equal to 0. That's who's not allowed. Okay. Compositions. Y'all remember seeing like the little Russian nesting dolls? Like first Toy Story, the little bulldog opens, the little bulldog opens, little bulldog opens, right? Or maybe you've seen the food chain thing, the worm, the little fish, the big fish, the bigger fish, the whale, right? Well, the whale still is technically getting the worm. It's just this went into that went into that went into that. Combo meal, okay? That's what a function composition is. See, if the function rule is just an expression, then I'm allowed to take that expression and put the entire expression, combo meal, in for x somewhere else. So you remember those as likely fogging off. Okay? So it's written like this, but what it means is normally I have f of x. Everywhere that there was an x, I'm putting the g of x rule. Okay? So instead of plugging in a 5, instead of plugging in a -8, instead of plugging in an a, I'm plugging in the entire 6x minus 2. Okay? Now it's important to note that when you do those, you work your way backwards. If I say f of g of h of x, that means I find h of x, plug it into g. Whatever that result is, I plug it into f. Okay, just like that food chain chart. You start on this end and work your way backwards into the big shark. Okay? Or whale or kraken, whatever it is. Okay. So, it says find each of the following. When we did this in Algebra 2, there was heavy emphasis on just plugging in a number and finding that answer. And I said, but you have to know how to find the rule, not just the answer. You got to find the rule. Because now they expect that you can just find the rule. So, if f is this stuff, then here, equals, then f's purpose is to take something and square it, then add 1. That is the f rule. So if I'm saying f of g, I'm plugging g into f. So if I have f of g of x, the entire g of x rule goes in. Okay? And then you simplify it. Don't square like a freshman. That's x squared minus 8x plus 16, then plus 1. You cannot just square x, square 4, call it good. Okay? Don't square like a freshman. We're doing ACT review this week. How many kids that, we ran across a problem and like 3 of the 5 possible answers, they squared like a freshman. And I was so proud to hear like 8 kids in the room all go, don't square like a freshman. Like, okay, good. We beat it into your head enough. Okay. Now, when I find the domains of these, you got to be careful because the domain of one becomes the range of the range of one becomes the domain of the other. Side quest. Y'all remember the function machines? The function machine, right? Input, output. The purpose of the function machine. This is what it does. Input, output. Grab chicken, throw in chicken nuggets. That is its purpose. Well, what's happening with the composition is you're saying g of x is here. So whatever I throw in to g of x comes out as g of x's range, right? Input, output, domain, range. But when I do a composition like this, I'm putting the entire g of x rule into f. So this is becoming the domain of f. And then chicken nuggets. So this right here is the composition of g and f together. I have to be careful that I'm not just looking at the domain of this. I have to look at the domain of the input function. Okay? The purpose of the machine is to make chicken nuggets. The purpose of the machine is to bread the chicken nuggets. Well, I'm not going to be able to bread Matt because I'm not supposed to throw Matt into the chicken nugget machine. Okay? If something's not allowed in g of x, I also have to exclude it from the final result. Okay? Again, after party, original party. So in this case, I got to double check. Are there any restrictions to the domain of the end result? Look at the input function. Are there any restrictions to this? It's just a line. No. So it's still all real numbers, but it will come up. And you have to talk about that. Okay, contestant 2 says g of f of x. So g, purpose, is to take a thing and subtract 4. I'm going to take f of x and plug it in. F of x is the entirety of, x squared plus 1. Okay. And then simplify it. And then I have to ask, are there any restrictions to the end result? Check the input function. Were there any restrictions to the input of f of x? No. So it's all real numbers. Where that's going to come up is what happens when I have like f of x is x squared and g of x is 1 over x. What if it's 1 over x minus 4? Right? I'm not allowed to have 4 in g of x, so when I do f of g, I got to be careful about that. Okay? Sometimes it shows up in the end result, sometimes it doesn't. And you just have to be aware of that. Now, f of g of 12. There's 2 ways to do it. Option 1, or 12, 2. F of g of 2 says, well, I've got the f of g of 2 or rule, or f of g rule. So I'm going to take 2 squared minus 8 by 2 plus 17. So 5, 9, 16, 1, 0, 4, 5.
What did you do, G first?
The f of g rule. If I have the rule, I can just plug it into the rule. Where I got to be careful is I already checked for restrictions to the domain. The other way says, go find g of 2. 2 minus 4. Negative 2. Plug that into f. Negative 2 squared is 4. 4 plus 1 is 5. Okay? So option 1, I have the rule, plug it in the rule. Option 2, to actually make it into G, into F, follow the chain. Okay? And they both have their merits because sometimes my function rule for the composition is really complicated. I would rather follow the chain. Sometimes the chain had a bunch of big nasty functions and the composition was actually pretty easy. I'll use the composition rule instead. It's a matter of preference as long as you watch the domain. As long as you're careful about the domain. So, we try it. F of G, G of F, F of G of 3. Go. I'm just going to make my pretty colors. I'm not going to actually do anything yet. There we go. And it's another one of those times where the parentheses are super important. So, as math teachers, we've been doing the ACT review all week long, and there was several times as we're going through them where kids just got caught in that trap of not using a parenthesis. Okay? They give you 5 options, and I guarantee you that 3 or 4 of them are, if you screwed up, you would have got this. Which is also how your final in here looks. I told you about that. Your final's multiple choice.
Did you say something about like looking at quizzes though? Like their grade? Or was that
If you get higher on the final than your grade going into the final, that's your new grade.
yeah.
Assuming you've done 80% or more of your work for the semester. Not going to have a kid who just doesn't do half the class and then gets a C on the final, so now you got a C for the class. Like, you got to play the game a little.
Is it just A or B?
Oh, we'll do both, but we're starting with A. I want to make sure we can do it right, then we'll do B. Okay. The purpose of F is to triple something and add 1. So if I say F of G, then I'm going to triple G and add 1. So negative 3x squared plus 15, 16. The purpose of G is 5 minus a thing squared. That thing is going to be all of f of x. Square it, not like freshmen. Watch your signs. You'll have a negative 9x squared, 3, 6, negative 6x, plus 1, minus 1, 5, plus 4. Okay, so square it, but not like a freshman. And watch your signs. Another thing, see how you got a squared locked on there? Exponents come before multiplication. Do not try to distribute a negative 1 in there and then, okay. See, because if you try to take a -1 times this, it's squared. You just applied a -1 to both of the factors. When, if I take, I don't know, 5 times 3 times 6, I don't take 5 times 3 and 5 times 6. I only take 5 times 3, then whatever that is, times 6. Okay, so don't distribute into a square. The same way that we don't want to distribute into absolute value or distribute into a radical. You got to be extremely careful with those things. Okay, domain. Both of those are quadratics. Quadratics are polynomials. By definition, polynomials have a domain of all real numbers. I just have to check. Input function. Were there any restrictions to g of x that weren't allowed? Okay. I have to check the input function. Were there any restrictions to f of x? No. So they were both all real numbers. Yay. Now hold on. Yeah, he's going to change the problem. No, I'm not going to change that one.
Oh, well, I already did it, so,
Yay.
yeah.
But more room though.
I know, it kind of sucks that much room we're getting.
Squared 2x, 4x, 24x, 4, 6 plus 24 plus 20. Yay or nay?
Yeah.
Let's be very careful again when you square. If you have to write out the binomial, x plus 2 times x plus 2, and then FOIL, do it. Okay? You use the skill that works for you. If you got the mental math mojo, do it. If you don't, don't. If you are exhausted because you were up until 3 a.m. doing the thing you should have done the night before, maybe you should write it out. Caldo. So, yay or nay? Cool? Oh, I suppose in both of these cases I didn't do the f of g of 3. Since the domain was all real numbers for both the input and output functions, for both the compositions and the inputs, 3 is legal in both. Where's ugly? No, we need ugly. No, we don't. Somewhere with one of these, just cross one of them out. We got some space here. Oh wait, is that just the next example? Am I shooting it? Ha! Okay. I was about to go and do this because I didn't realize that was the next one. All right. These ones have the restricted domain. This is where we have to look out. Find f of g. So we'll just start with this guy. The purpose of f is to have 1 divided by a thing plus 1. That thing is going to be g of x, which is x squared minus 9. I simplify. And then I ask, is there anything not allowed to the after party? Okay. Set your denominator equal to 0. Don't you dare write square root of 8. We're big kids. We're going to simplify it. Although we ran across an ACT problem yesterday where they didn't simplify it, and all 3 of the math teachers just like started twitching. So, right. But then, okay, so I just said that negative 2 root of 2 and 2 root of 2 have open circles on them. They're not allowed. Those are the only things that aren't allowed right now. Go back to your input function. Was there anything not allowed in there?
Yes. Or no.
The input function had a domain of all real numbers. So I'm good. And I do have to check both because sometimes one is more restrictive than the other. Okay? Like with our and or stuff, you got to make mom happy and dad happy. Well, what happens when one of them is more strict than the other? Okay? Not or. Not or. You don't pit your parents against each other. Okay? No or. So my domain will be negative infinity to negative 2 root of 2. Can't touch this. Negative 2 root of 2 to positive 2 root of 2. Can't touch this. And then from 2 root of 2 to infinity. Triple union with simplified radicals in it. That's why we had to know algebra 2 to come up here. Okay. I did the first part. I'm not going to look at B yet. I would like you to find G of F. I want you to also find G of F. G's purpose is to square things and subtract 9. Squaring a fraction, square both parts. Don't square like a freshman. If you want to get real fancy, multiplied by x squared plus 2x plus 1 over x squared plus 2x plus 1. Common denominators. Multiplied top and bottom by that quadratic, and then combine like terms. Okay? You do not have to go to purple. I'm just saying, if you want to get fancy, there it is. Domain. Look at the after party. Who's not allowed? -1. That's the quantity x plus 1 squared. Go back to the input function. Was there anyone else not allowed? No. So that is the only thing that I have to exclude. -infinity to -1, can't touch us. Now. And -1 to infinity. Okay, now, part B. This is where I got to watch out with my end result. See, f of g for both. All right. F of a thing, its purpose is to square a thing minus 2. The thing, in this case, is going to be g of x, which is the square root of x minus 3. So this is where we were going with all of this. Pink. What happens when I square a square root? Kapoof! And I get x minus 3 minus 2 is x minus 5. This is why we have to understand how domain and range work with a composition. If I'm only looking at the after party, it says it's linear. Everyone's allowed to this party. But I have to go back and check who was allowed into the party in the first place. Okay. 3's okay. I know his dad.
He's kind of iffy, but
He's on the edge. He is literally on the edge. That is the minimum we will take is 3. Okay. Not his brother, no. I've had families like that. Like where this brother actually does stuff and does really well in class, and this brother turned in 4 assignments for the entire semester and wondered why he had a 19% on the final. 3 and up, right? So even though this is linear, even though it looks like it should be all real numbers, 3 to infinity is the actual domain. Now the reason that's important, what happens if up here in my directions I said find f of g and f of g of 2? In the first one, 2 is not one of my restricted values. I'm allowed to put it in. We're good. In my second one, 2 is not one of my restricted values. I'm good to go. In my third one, if I didn't look back at my input function, I would think, all right, 2 minus 5, -3, I win. but 2 is not allowed into, okay, I cannot bread the Matt nuggets if I'm not allowed to throw Matt into the chicken nugget machine in the first place. Okay? We're picking on Matt because Matt decided to stay up until 2, 3 in the morning before he figured out I have to do English now. God, dude. All right, those two. Give them a roll. You got to get the goo on there first for the crumbs to roll around.
Are we just doing fog for these two?
Yes. Just fog. Don't do that. Same. Revenge wakefulness. It's when you feel like you can't control anything else in your life, but you can control when you go to bed. So you stay up doing a preferred activity instead of going to sleep like you should, because that's the only time you know you can do the activity.
I need to record that and then send it. It's like, staying up is the best thing ever.
And this is the only thing that matters. We don't care about that one.
Well, that one will be taken care of at the end of it. So you check the end, you check the input.
Okay, so what do you include that one? Or just that?
So your end result is just X. So
And then
no
that,
restrictions.
so there's just no restrictions.
This is correct.
Okay.
This is just a polynomial, so that has no restrictions. Altogether, no restrictions. But then, what if I did g of f? You know what? Yeah, we need to have that conversation. I want you doing both for these. I want you finding both. Because that is a conversation to be had. Find fog, find goth. Is it? Rick, Lightning Thief. Rick Riordan is not just a good author, but he's an amazing human being.
Yes. I read all of the books in the month.
Yep. I love reading them. Just they're nice and simple. They're not complex, but they tell a good story. He has wonderful inclusion and diversity in his books. Like, he's a genuinely good person. Unlike certain other notable authors that shall not be named.
Okay. Big choice.
Yeah, Burning pretty cool too.
Did you know that the mayonnaise were actually made by a kindergarten teacher and she sent them to him and he wore them at the inauguration?
They're both.
He ain't perfect, but he's pretty good.
Yes.
All right. Interestingly enough, does anyone remember what that means? Louder? Inverse. The input is the output. If I do a composition of functions and I get the identity, that's an inverse. These swap x's and y's. Now the problem is they both look like identity, linear, all real numbers. But I have to check the input function. Okay, yeah. Check the input function. Specifically from -1 to infinity. Which is why you may have seen in the past, when you were doing inverses back in Algebra 2, right next to this one, they would say where x is greater than or equal to -1. That was the only way to ensure that they actually were inverses, is by restricting the domain of 1 so that when I do the composition, they'll both be legal. Okay, contestant 2, Fogg and Goff. A little faster. F of g of x is just 5 over x squared plus x. Not allowed to be 0 or -1. And g of f of x is Goff. Plug this in here and here, getting 5 over x squared plus 5 over x. If you wanted to be fancy about it, again, I could turn that into 5 plus 5x over x squared. And thou shalt not 0. Okay. So, you notice that most of what we're struggling with here, it's not actually the mathematical operations, not the composition itself. It's the domain. And this is why, a couple days ago, a week ago, I'd said domain is something that we do not stress enough in Algebra 2. I would like to, but every time I do, my Algebra 2 classes, their eyes start to glaze over a little bit. Well, now we have to because it really matters. It's important to the analysis of the function. Okay? Again, the difference between Algebra 2 and PreCalc. Pick up where you left off, dial it up to an 11. Can I? Square both parts.
Wouldn't that be 25?
Oh, that's a 25. Don't do mental math when sleep deprived, right? Yep, there was a 25. I did the dumb. Okay. Okay, decompose real world. Oh, we're so close. We're so close. We're we're not going to finish it, though. We'll cut it off there. So close.